then let's say let's start with an exercise 1. Okay, so beam exercise 1 C. So let's try our first C code. Okay, so I will explain what each line means when as I write them. Okay, so okay, there was a hands up. Okay, that's gone. All right.
مرحبا. لن أطلب منك إعجابا أو أي شيء غير أن تركز
when I write this code,
وتنتبه
I'm
معي في
gonna write
هذا
the code
المقطع.
in the first place, and I will explain what they mean line by line. Okay, Derek, you have a question? Go ahead and unmute. Right.
مرحبا.
Okay, so Derek, when as I write them. Okay, so okay, I guess okay, there was a hands up from Derek. Okay, that's gone. All right.
مرحبا. لن أطلب منك إعجابا أو أي شيء.
C is technically, if we think about it, C is a very old language, and it's also kind of one of the it's like the father of language, the modern language we're using right now. What I mean by that is those languages that we use more regularly than C right now, like Python, JavaScript, C++. So C is kind of the father of modern language. So that's why we're learning C. Okay, the reason we're learning C is one, it's right now, as I said, it's the father of all language, more modern language, and the other one is it takes the most of the modern language draw their philosophy or their programming philosophy from C. Okay, so when you understand C, you basically have a fundamental understanding of most languages we are going to use. Okay, so you're going to learn about JavaScript and Python in your next sprint. So you will have a chance to see those philosophies, those programming philosophies here on C. Okay, so I see on Slack there is a problem. Okay, so we're going to fix that later on. Can't fix it now. So that's why C is chosen so that you understand the important concepts in software engineering world or in the coding world. Okay. Someone can go to the announcement channel and comment that the session is being recorded, so it will be shared. I know the Zoom session is full, but there's nothing much we can do right now. So please just go ahead and write that for me. I will appreciate it. But okay. Also, comment.
Yosef, I don't think we have the right to comment. Maybe if there's a thread. Oh, okay.
So there is a thread. So on the announcement channel, the last post I made, if you can write on there, that would be nice. Thank you. I made a Springer here. All right, so this is the first code we're going to look at. Okay, so this is a very simple code. It's going to only print out one statement to our terminal. So let's see what each line means. Okay, so the first line, it starts with the pound sign, then include, then with greater than sign and less than sign, there is a stdio.h. Okay, so std stands for standard and io stands for input output. Okay, so what does include do? So what include does is it imports the content of another file, okay, another code base into our code base here, okay, our source code here. So our source code right now is this, the one which you're seeing right now on your screen. So by using include, what we're doing is we are importing another file content to this source code we have right now. Okay, so what does that file content has, which is right now the file content we're including is standard input output header file. Okay, so the standard input output file, what it contains is it has different functions that we are going to use in our programming in our program. Okay, so this is a very important concept in programming. This concept is called reusability. Okay, so we can create everything we're doing right now by line. Okay, so we can create the printf functionality ourselves, we can create the main functionality ourselves, the variable declaration functionality, the return functionality, everything in here we can create it ourselves. But that would mean we're reinventing the wheel every time you're writing our code. Okay, every time we're writing a code, we're reinventing the wheel. Okay, it's like you were asked to build a car and you're just starting with designing a wheel again. Okay, that wouldn't be wise, right? So we understand what a wheel is, we don't have to redesign it again. Okay, so that's why we're using the include functionality here. Okay, so by doing that, by using the include keyword, what we're introducing to our program is the concept of reusability. So there is already made a lot of functions lists in standard input output header, so that those functions are going to be imported into our file. Okay, so the include functionality is used to import functions written by other people. Okay, so another thing is C has a convention of using the .h extension for header files. Okay, so these header files are the files that will be used everywhere. Okay, so we're going to create our own header files later on in the library sessions, but for now there are header files placed in our system, and those header files are going to be used. Okay, so those header files are going to contain different functions that we can use to do other functions, to solve our own problems. Okay, so the next line, so this is not a command, rather it's comment. So next line is a multi-line comment. Okay, so what I need you to see here is, what I need you to see here is a very important thing is a multi-line comment is introduced using the forward slash and an asterisk. Okay, and it ends with an asterisk and another forward slash. Okay, so what it means is you can write a comment that spans multiple lines with this tag, basically. Okay, so why do we need comments here? So comments are important because our you can hear me fine, right, guys?
Yes, we can hear you.
Yes, we can hear you fine.
All right, just making sure.
So yes, you can hear you.
So a multi-line comment or a comment in general is important because we need to make sure our code is readable. Okay, so another concept, important concept in programming is readability. Okay, you can write a code without any comment, without any tabs, without any indentations, and without any line separations. But the problem is it's going to present is it's going to make your code very unreadable. Okay, so one thing you need to remember, so this is something that I will be sharing from experience. You will forget what you wrote in like a week. Okay, so commenting will help you a lot. Okay, it might be you might not forget these small lines like this, the one you're seeing on your screen right now, but when you are building large systems, you will forget what you wrote a week ago because you're juggling a lot of things. Okay, because you're writing a lot of command lines. Okay, you're writing thousands and thousands of lines of code. All right, so commenting is important so that one, you can save yourself from a headache of remembering what you wrote and what was your train of thought was. Another thing is, if by any chance you move on from the project and another person takes that source code, then the new person can use that comment as a documentation. Okay, so the new person can use that comment and understand how the program works and what kind of changes he can make or she can make. Okay, so that's what makes commenting very important skill set. Okay, so let's go to the next line. What's the next line? The next line is int main, in parentheses int argc, comma char argv, asterisk argv in an array. Okay, so this line, what it does is, so it's basically telling the operating system where to start running the program. Okay, where to start running the program. So the way C program works is that the operating system loads your program. Okay, loads your program, and then it returns the function name and the function named main in our here. Okay, so the operating system takes your source code, loads it into the CPU, then it returns the main, basically. Okay, then the main is the one, the main function is the one that's going to be executed. Okay, so this main is basically the starting point. Okay, it's basically us telling our computer, you're going to start running this code from here. Okay, from location X. Okay, we're marking where the computer should start running the program. Okay, so that's why by convention we said int main. Okay, so if you have multi-file code, source code, that means you have header files and you have other files you are importing to your core source code, then your computer wouldn't know where to start if there's no main. Okay, so if you have, for example, in your source code folder 20 files, how would your computer know which file to start with? Okay, so in order to help your computer where to start running your code, you're going to say you're going to include an int main in your core file, basically. Okay, so int main is basically telling the computer this is where the starting point of my code. Okay, so int main can have two arguments. These are called arguments. Okay, so that's why we named them arg in here. So two arguments takes it's a function, so it takes two arguments. So we'll talk about functions later on, but think of functions as some kind of machine that takes an input, then spits out a result, basically. Okay, so imagine them like that. Okay, so think of a black box, takes in an input, then spits out a result. All right, so inside it does a lot of things. We will talk about functions later on in another live learning session, but for now, int main is a function and it takes two arguments. The first argument is the first argument is argument count. So that means it takes the number of arguments it's going to take. Okay, so by giving this argument, for example, 3, what we're saying is expect 3 arguments that will be inputted to the argv argument. Okay, so don't worry, I know this is confusing for now, but we'll talk about it in the library session we'll be holding on functions, what it means. But for now, what we're doing is we're giving argc the number of arguments that argv will be taking. Okay, that's all you need to understand. Just leave it for now. Okay, put a pin on it, basically. So another thing you need to notice in this line is the int part here. Okay, so before the name of the function, that is main, there is an int here, int. It stands for integer. What it means is it will return an integer value. Okay, why do we need an integer value returned? Because it's on an operating system needs to know if there is if the program is ending or not. Okay, so by returning an integer that is 0 in our case, what we're doing is we're telling the operating system that this program has executed everything and is done with the rest of it. Okay, so no need to run it again. Okay, that's what we're talking about. Okay, so before I continue further, Loy, you have a question? Loy, go ahead.
Do you hear me now?
Yes, I can hear you now.
I'm sorry if I raised my hand in the wrong time. I had something to say, but it's not necessary to be a question at this particular point. So if this will interrupt you, I can just delay to the end of the session. I'm sorry. If
is the question related to the concept you're talking right now?
Yeah, but not what you were talking about right now. It's about the C in general. I think that I came up with something that I was studying before I joined the ALX, and it gave me some more knowledge, and it made C super easy, and I loved it, even if it was low level language, and it was hard, but I loved it because of this manipulation. So if you want me to speak about it in just a couple, maybe 1 minute, I would.
Yeah, go ahead.
Okay.
Go ahead.
Actually, before I joined ALX, I have finished this semester from Harvard. It's called CS50. CS50 is actually basically the best. It's an introduction to computer science and the enterprises of computer science and the art of programming by Harvard University. But actually, he's the #1 professor in this computer science, Professor David Malin. He's a professor in the practice of computer science. He's not just a big programmer or something like that, but he's a professor in the practice of programming. We basically started the first CS50. Just to wrap up everything, I want the people here listening to me to go just not to attend the semester or to study it or even study the lectures or all of it. Just watch the first 5 lectures. Just watch it. Don't interact, because it will take you so much time to solve the labs of the week, the projects of the week. No. Just watch it. He made a kind of manipulation of the sequence of the concepts. So he made everything make sense and everything make easy from week 2 to from week 1 to week 5. We started by the first week is scratch. We understood the computer, how it works, some about the Scratch programming language. It's a graphical programming language made by MIT. And then we started looking at C, then arrays, then I think memory, algorithms, data structures, but all in C. It takes you basically 3 months, but we just have to watch those lectures. It made everything make sense in a sequence. He manipulated the sequence of concepts, made things before other things, so everything seems easy and everything makes sense for you. You are not studying something hard and you want to understand it and you're struggling with it. No, everything was really easy. And as I told you, it's the first. It's if you look for statistics, he's the number one. It's the number one computer science course. I finished it all. So it's not the time to speak about it, but I just want to make this suggestion. I hope I didn't take so much time of yours, and forgive me if I spoke for a lot of times.
No, it's fine. Thank you for sharing it. I will share the link with you guys on Slack as well. It's a very good suggestion. Thank you for that, Loya.
Yeah, and just watch the lectures. You don't need to do anything else. If you will interact, that's fine. But the necessary. Thank you.
Yeah, thank you for that. Sharafuddin, do you have a question?
Yeah, good evening.
Hi.
Okay, so I'm kind of curious why you chose argc and the pointer array argv as your naming convention. I know arg is for arguments, but I don't know what the c and v actually means. I like knowing the meaning, so I won't forget easily.
So argc means argument count. That's why I'm using argc. Argv means argument variables. So the values, argument values. I mean, the values that we'll be sharing, passing to the main function later on. But for now, I'm just saying that main will accept 2 arguments. We're not going to command line argument. We're not going to talk about command line arguments for today, but I will show you what it means later on. Okay.
All right. Thank you.
All right. Hi, Martin. I didn't see you there.
Hey, Joseph. I just want to comment on argv. Hi, everyone.
Yeah.
Argv stands for argument vector. Why is it a vector? Because it is a pointer to an array. It's a pointer to an array. So actually, it has, you could say, it has a list of pointers. So it's a yeah, you could say in higher level languages you could call them strings, right? But it's a pointer to a char, and all of them. So that's why we call it an argument vector, because it's 2-dimensional, right? It's each of them is the start of a string, you could say, or an array of characters ending with a null byte, of course. So that's why we call it argv. It's a vector, just to add to your
So we will see what's the bigger picture when we talk about pointers and why we talking about why we're using the asterisks and why we're talking about the argument, the array, and why we use the character as to store our strings as well. Okay, so we'll talk about it when we talk about pointers. All right, guys. Thank you for that, Martin. So Chima, do you have a question? And if I am butchering your name, sorry about it.
Yeah, sure. That's no problem. I wanted to ask, okay, well, you just made it clear to me now that you'll be taking us some pointers, because I would love you to like explain a lot on pointers, because I think I got lost, just like I told you, from nested loops then down to pointers. So that'll be cool,
Yeah,
please.
so we will have a session for that, explaining pointers. One big session, 1 hour block, talking about pointers. I just wanted to cover, just wanted to focus on this session on the basics of C, so that we don't confuse a lot of things. That's why I started off with this library session. Okay, so we'll cover pointers very soon. All right, don't worry.
All right, thank you.
Yeah. Daniel, do you have a question?
Yeah, mine is a general question about the live learning sessions. We used to have it every week, but along the line, there was a break in it. And it has made some of us got lost on the way, especially from where my brother was talking about the nested loop to the pointers. So I want to know how often this one is going to be and how we'll be able to match it with the tasks of the day that we used to have.
Yeah, so we'll be having live learning sessions from now on for 2 live learning sessions every week. The dates will be announced every Monday. Okay, so the gap you mentioned was because Colin Faith had to hand over to me and I was handling another cohort. That's why that gap occurred. But don't worry, from now on we'll be very regular about it, and we will have live learning sessions, at least 2 live learning sessions every week. Okay, don't worry. All right, so let's continue to the next line. So we talked about main. So now the next line is a curly brace. So what does a curly brace introduce on C? It introduces a block, okay, a block of code that is related to the function above. Okay, so right now the function we're talking about is main. So everything related to main, or everything that will be executed by main, will be in this block. Okay, so that's why a curly brace is to notify you that there the block of the function has started. Okay, so as I mentioned previously, or a couple of minutes ago, you can think of a function like a machine that takes on an input and manipulates things and gives you an output, right? So the inner workings of that machine can be analogous to can be related to the block in here, the block referenced in these curly braces. Okay, so the curly brace, when it opens, that means we're inside the machine right now. Okay, so after that, so to start any function or the body of a function, what you do is you open up a curly brace. Okay, so after that, we have variable declaration and assignment. Okay, so declaration and assignment are 2 different things. Okay, when we declare a variable, what we're doing is we're just mentioning the type, okay, and the variable name. Okay, so declaration is till here. Okay, so the one I just highlighted. Okay, so the type of the variable, then the name of the variable. Okay, then assignment means when we put the value to that variable. That means assignment starts from the equal sign to the end here. Okay, so what is a variable? So a variable is a memory location. Okay, you can think of a variable in C as a bug. Okay, that has a name distance, for example. Okay, the bug's name has a tag that with a name distance. Okay, and the bug can only carry an integer. That's what we're saying. Okay, so this int represents an integer, as I said before. So the bug can only carry an integer, and the bug's tag or the bug's name is distance. Now, we didn't put anything in that bug in the first place. So we just declared the bug. So declaring the bug means basically making it into exist or creating it into existence or bringing it into existence. Okay. So we declared the bug. Now we placed a value into it, which means 100. Okay. So that we stored a value into it, which is yes, bug bag. So we placed the 100, the value 100 into it. So it can now it can carry it carries the value 100. Okay, so that's basically what a variable is. That's the analogy of it. So a variable is a memory location that stores a value, basically. Okay, so in our computer we create a memory location, and that memory location has a name of distance, and the distance the distance name reference to the value inside that memory location, which is in our case 100. Okay, so declaring a variable and assigning it has a format of the type of the data, then the name of the variable, and the assigned value. Okay. All right. So the next line again is another comment. Okay, so there are two ways of commenting your code. One is a multi-line comment. I showed you that in the second line or in the third line, which contains the forward slash and the asterisk. The other way of commenting is using the forward slashes. Okay, the double forward slashes. Okay, so this also a single line. This is called a single line comment. So you can't use this to do a multi-line comment. You only use this one to comment one line. Okay, so a handy way of using this one is besides commenting is if you want to, for example, if you don't want to remove a line of code, but you just don't want it to be executed, you can use this one line commenting style to get it out of execution. Okay, so what I mean by that is, let me show you. So for example, I don't want the printf to run. So what I do is I add, okay, it looks like my sandbox is stuck. I'm gonna start it again. So if you're not talking, make sure your mic is on mute, okay? Okay, so what you can do is you can add a double forward slash, and what you basically did is printf will not be executed. Okay, that's what you did. Okay, commenting, it's called commenting it out. Okay, so it's called commenting it out. That means this line of code will not be executed when you compile your function. Okay, so that's what it means. Right.
So Joseph, why are you not coding in Betty style? This would not be approved by Betty, right?
Yes, I know. But
I mean, it's a good thing, you know. This is also part of the show we can do is just to run Betty on the file and see how we can fix those issues. So maybe later you could also go into that.
Yes, it's just a new sandbox I just ran, so I haven't set up the Betty. That's why I haven't been running Betty so far now. But I will run Betty later on.
No, this is also a good showcase, right? Because now we can see, and some of us already identify that, hey, wait a minute, Joseph is not exactly aligning with how Betty would like to see the code. So it would be nice if you could also show and run Betty on this exact file later on, and to see how we can actually identify the things that are reported in order to fix them.
Sure, no problem.
Thank you.
All right, so just continue. So you have also your line of code, one line of code commenting. So the next line is printf. So printf is another function, and the printf function is imported from the standard input-output header. Okay, so the printf function is used to print out a statement or a content to our terminal. Okay, to the standard output basically. So the printf function is a function that takes multiple arguments or a single argument. Okay, so for now, what we did is in our printf function, we created a template string basically. So this hello, then you are, then %d miles away, then /n. Okay, so this contains a lot of things. Now it contains a string 1. So a string means a bunch of characters or a bunch of statements. Now the other one that the other thing you need to notice is the formatting here. Okay, so you can input data or dynamic data into your string. Okay, so by changing distance, you can change you can manipulate the statement, or you can manipulate the output of the content of the output by changing the variable outside, okay, or the distance basically. So here the %d is telling us that this one I will only accept the integer value. Okay, an integer value. So the %d needs to be an integer value in order to be printed in this. Okay, so the d stands for decimal, so it needs to be an integer value, so that the formatted string the printf can understand it basically. Okay, so another thing you need to understand is the escape character here. Okay, so the escape character escape characters are characters that are special way of things to be formatted on. Okay, so the /n, what it will do is it will create a new line for us. Okay, there are other escape characters. I suggest you look at them. If you're not talking, make sure you're on mute, guys. So the escape characters are special characters that help us include different kinds of formattings. Okay, so the /n means a new line will be introduced to the printf. Okay, so hopefully you understand printf. We'll talk about printf more in later on, but for now this is what it means. So the next line is return. Okay, so a return from the main function basically gives, as I said before, gives the operating system an exit value. Okay, so the exit value here being 0. Okay, so an operating system needs an exit value because it needs to know where your program ends. Okay, it needs to know where your program starts as well. That's why we're creating the main function, but it also needs to know where your program ends. That's why we're using the return function here. All right, hopefully that's so far it's clear. Alex, do you have a question? Alex?
I'm asking,
okay,
when do you know when to use a return and when to use a void?
When do you know to use a return, and when do you know to use a void?
Yeah.
So when you're using C, it's usually we're going to use int to return 0. I don't remember using C void. So so void means you're not returning anything, basically, right? So I don't think we're going to use void in C. I don't remember using that, but I will check. Okay, Martin,
So,
yeah.
yes, so it really depends on how you design your software. I can imagine that if I have a function that that only prints to std out, there's no really need to return to the calling function. Remember, every single function returns a value to the calling function, right? When a function like main is called, this is by convention. The name that is used in C that will be called. So, and by convention also, it returns an int, which is the status, right? So, as we have learned also in the shell projects, when we execute a program, a 0 return value is success and a non-zero return value is a error. And back in the day, people just could come up with any kind of return value for their program in case of an error, just for the calling program to actually be able to handle it. But a 0 return value always means it's a success. So this is important for the calling program, right? The program is called and it returns 0 in case of the main function. If I create my own function in C, usually it would return something that I then would use in my calling function. I can either pass around a variable and then use that variable and return something else. So when I call a function that I've created myself, of course I have a prototype. I create my function with arguments and the return value. So and then in my calling function, which is in this case main, in this case printf is called, which is a standard library function, but it is a function nonetheless. When we look into the manual, I haven't seen the manual yet. Joseph, where's the manual? We need to use the manual. We need to learn to use the manual. So I would recommend.
I will be opening that later.
No, but because the thing is, when we start exploring things, the first thing would also be nice to start with a manual.
Yes.
So that's a good thing. I mean, even me, I also learned all these things through the manual. I mean, back in the day, we didn't have internet, so and World Wide Web. So I must say that you are blessed having all these access today. Zoom meetings with people that are millions or thousands of kilometers away is great. Anyway, you can use the manual to see why we do things. But the question is, why are we sometimes returning void? And why are we sometimes returning a non-void value, which could be, in this case, it's an int, or any other data type that you have? It really depends on your program designs. But as Joseph rightfully stated, it is probably will return a value. But we also know, and this one's something we learn later, if you pass a pointer to your function, you don't necessarily need to return something. And more about that later. But that's also something interesting too, to take into account that if you have a function call, they can easily return void if you're doing something with the pointer in your function, because then you'll learn about it as well. So that's in case you pass the pointer to your variable, you might as well just return void, because you would do something with the value of where the pointer is pointing towards. If you are returning a value from your function, then you would return that value. In this case, int main, of course, we must return a value because we cannot pass a reference to a pointer to an outside function. like something else executable that's calling your main or your executable that's being compiled from this function. So in this case, we would also always need to return int, which is by default, by convention, main would always return int. That is just how, but we do have to take into account the main function is not a prototype because there are different variants of the same. But for all the other functions, we always have to have a prototype if we have more than one file. Anyway, so much for me on the return value.
Yeah, thanks for that, Martin. So basically, if your function has an output, we go back to our analogy for just a second. If your function has an output, then you might have to specify the data type or the output type, basically. But if you don't have an output or your function processes things and doesn't return anything, then you use void. That's the analogy you can use. Okay. Okay. Aya, do you have a question?
Yeah, I wanted to ask you, how can I run the program inside the command? Because every time I run it, I have to use a program outside the command to check about this and put it copy paste.
I didn't get that. Sorry. Can you say that again?
Yeah, I wanted to ask, how can I execute the program to know about this program is doing it well or no?
Oh, so we're just going through the code base right now, but I will show you how you can also execute the code base. Okay.
Yeah. Okay. Please. Thank you.
Yeah. Alfred, do you have a question?
Yes. Thank you. My question is about the comment.
So Alfred, you're breaking up. So maybe can you write it on the chat?
Go back to the field.
Alfred, we can't hear you, so maybe write it on the chat and we'll get to it, okay?
Hello?
Yeah, Alfred, can you hear me?
Hello?
Alfred, can you hear me? All right. So we can continue then. So the next thing we can do is running the function. Okay. So in order in running our code. So in order to run our code, we have to compile it. Okay. So C is a language that needs to be compiled before it gets executed. Okay. So anyone here who can tell me what compilation means? GCC is a compiler, not a compilation. So Shazad, do you have something?
Yes, I guess compilation process is the process where I can convert my source code into a file which contains this machine readable language, so it can be executed. And we use GCC as a compiler to see its execution, to see if it is running right or wrong, or how the machine read my source code.
Mm-hmm. Exactly. So Loya, do you want to add on Shazad's point? Thank you, Shada, for that.
Thank you.
Loya?
May I add?
If you're talking, your mic is on mute.
Oh yeah, I was speaking. Yeah, thank you. I was saying basically, I have a question that is, it seems, burning question for me actually. I see that we are compiling our source codes with using the standard 89 or 98. Yeah, no, 89. I'm sorry, 89. So I'm wondering why we are not using standard 99 or even 92. So why are we using older version of C? Is there's a major differences, or there's something that is getting us some experience, and then we can use the later versions freely? I want to answer for this, please.
So you can, I mean, currently we're just supporting the 89 version, but it's not, we're not saying you can't use the 99, but the reason we're just working on the 89 is it's basically we're using C so that you can learn the core understanding of the core concepts of programming. So it doesn't really, it's not really a focus point for us to use the 89 or the 99 for us. Okay.
Yeah.
And Martin, do you want to add something on that?
Well, the reason why, like, if you are used to C89 or 98, I'm always confused. You can also use the same writing in newer versions, but the other way around is not. As well, knowing C, like we are laying a foundation, right? For most of the things that are added in C90, C99, and CC. So most of the things that are added, no, these are nice to have, but also some things that we are using, we are, especially in the first part of the program, we are basically rewriting, writing the common functions from the standard library for ourselves, so that we begin to really understand under the hood. We are not creating a car of parts, but rather we are learning to create the engine and to understand how it works, right? Not to the fullest degree. We're not designing and creating Windows operating system, but for instance, but we are having a foundation understanding of how everything works on the level of memory management and everything so forth. So that's why it is not necessary to use C99 as well. It gives us some liberties that would prevent us to really being able to check your code. Because then solutions can be written in different ways and different styles and different answers. So by using an older version, it makes it easier for us, that is the intranet, you could say, Betty, and to really be able to check your code. When we start using newer versions of C, it also means that there will be a wide range of different things we can introduce to solve a certain task. So this is also a reason why we want to stick with an older version. Notwithstanding, using an older version of C does not mean you'd learn less. And you can easily just learn about the newer features once you start maybe working on embedded systems, because that's usually why C is used anyway. When you start working on embedded systems, or maybe you want an optimized library you want to create to use in some other scenario. But that's mainly the reason, is because it restricts you, so you can solve things and learn things, and then later, if you want, you can always start using more kinds of ways to solve certain programming problems using different ways of writing in C. So this is basically, yeah.
Yeah. Thank you so much. I think I just want to make the distinction so not people misunderstand me. Because I used first to use the standard 99, so I feel some slight differences, but it's okay to learn any standard. And just to make sense for people to understand this, the differences are slightly easy. Like you can declare the function at the beginning of the main or in any way else. So it's just a slight differences. So not people get afraid. Oh, we are using older version. No, it's almost the same. And yeah, thank you so much for your answer. Thank you.
All right. So compilation. So let's talk about compilation. So compilation means basically changing a high-level language into a machine language, basically. Okay. So a machine language is zeros and ones. So as you can see, what we wrote in on our code here is quite similar to the language we are using right now, right? So that won't be understood by the computer. Okay, so we need to compile that code into a machine language. Okay, so we need to compile it into a zeros and ones. Okay, so that way we can use that zeros and ones to execute our functions or our code, basically. Right, so compilation means changing one form of language or our mostly human readable language into a machine language. So that's why we need our beloved GCC. All right, so before we start using GCC, let's talk about manuals. Okay, so we can read about GCC using, we can read about GCC and we can understand what GCC means using a manual. All right, so and what kind of functionalities, what kind of options does GCC offer, things like that. We can talk about that. We can read about that using the manuals provided to us in our machines. Okay, so in order to use manuals, what we're going to do is we're going to do man run GCC. Okay, it will open up a manual for us. Okay, so as you can see, since it's zoomed in, it might not be as visible, as good of a visibility. So let me zoom out. And let me zoom in a little bit. So here, what I did here, let me do it again. What I did is I used man, it's short for manual, then GCC. It will give us the manual for GCC. Okay, so here you can read about the options GCC offers, the description of it. So it tells us what it does. So for example, when it says when you invoke GCC, it normally does pre-processing, compilation, assembly, and linking. These are the four steps of compiling a C code, right? So pre-process, compile, assemble, and link. Okay, so the overall options allows you to stop this process at an intermediate stage. Okay, so if you want to stop it at pre-processing, if you want to stop it at compilation, if you want to stop it at assembly or linking, there are options provided to you as well. Okay, so there is a very detailed description of things. Okay, so if you remember when you run GCC, you were using W extra, W error, W all, those options, right? So if you want to understand those things as well, the explanations you can find in the manual page. Okay, here you can find them a lot. So it's a very long manual, but it's a very important one. Okay, so you need to understand how to use manual pages, and it's very simple. You're going to use man, then the tool you want to read about. Okay, the name of the tool you want to read about. So it explains everything. So what it if you're going to use O, for example, it tells you that the option O. If you use the option O, it places the output file in file. Okay, the file being here is the file name, right? So this applies to whatever sort of output is being produced. Okay, so it explains everything and how it's going to do it and how you can use it. Okay, so make sure to use manual pages when dealing with different kinds of command line tools. Okay, so remember man GCC, it gives you a lot of it. All right, so if you want to learn more about manual pages, just use the framework and Google it, and you will find more functionalities about manual pages. Okay, Marvelous, do you have a question?
Yes, Yosef, I have a question. I wanted to ask, first of all, thank you so much for the explanation, and I'm looking forward to more sessions, and because personally it will help me to tackle the project, and because I think I love to understand before tackling certain project. So however, the question I have, it's a little bit, it's not what we are covering today, but I think it's something that bothered me last time when I was working on a project. So this is the question. So when I'm working on a project, sometime to work quickly, I tend to try to run the code that I'm working on, maybe on an IDE that exists already, like code blocks, and just to see if if the output will be like similar, and then if I can confirm, then I will go. However, the last two projects I had difficulties because I do not know how to go about with the main file that we create. After we create our main file, because we are using our own prototypes, and we are kind of like trying to create the built-in file function that exists already, just like customizing it. So now when I create the main file on code blocks, I do not know how to, on the terminal I know how to do it, but from code blocks I don't know how to link my main file with the new code that I'm trying to. So I keep getting this error. I just don't know how to manage that. Does anyone know how to do that? And do you, I don't know if the question makes sense.
So correct me if I'm wrong. So are you asking, you created multiple C files, different C files or header files, and you want to import those files into your main code file? Is that the right question?
Yes, but it's just like I want to test the code from the IDE code blocks. So, but when I import the main file from code blocks, it's always run into an error. So I don't know, like maybe it's not supposed to work like that. Then
I'm not sure about code blocks. So Martin, do you have any idea about code blocks?
So I know that we want to use IDEs, we want to use online because we think it is faster, because it gives us maybe a little bit more like an experience that we are used to. Maybe we are used to posting things online. Maybe we are used to using the web interface to fill in forms, maybe posting things online in different medias we use, or we're just used to the browser. And that's fine, However, I would, instead of trying to fix your issue, try to move away from code blocks and start using a compiler from the command line. Because it does not take more time. You are writing the same code. You are actually doing the same exact thing. However, it will work. And this is why we want to teach you to use the terminal and the executables, such as GCC from the command line. Because, that's in the ultimate end, what you will be learning. You're creating for yourself a foundation, right? Right? And honestly, that is great if you do that. So I would recommend, and of course it's really up to you. If you want to persist in using web interfaces, But you can run GCC from your own terminal also, or if you use the sandbox online via the web terminal or via SSH connection, or you have something on your Vaker machine running, or maybe another virtualization technique that you use, it doesn't matter. But I do recommend you to run it just in your interface. I mean, in your command line interface, that will just do fine. There is no need to use those online tools, even though we feel like it comes more naturally because we are used to it. We have to swallow the bitter pill, but once we are used to the command line, we will actually experience, hey, it is actually not even slower or something, right? Because in the ultimate end, we are here to become a great software engineer. We are not an end user of a web terminal or a web interface, right? So I would recommend try and again to accustom yourself to certain standards that we are trying to help you get used to. And we have reasons for that. We have designed this program in a way that will help you as a software engineer in the longest run, right? So how would you feel that if you go to your new employer and you are going to the web interface to code your code, but hey, wait a minute, what is this guy doing? Really? How long do you want to keep on using the web interface to code your code? That's not professional, right? Even do you know what is behind that web interface? Do you know? I don't trust it. I don't know how they will use it. What if I put code there that is actually copyrighted code, right? These are all things I'm thinking about. Even though we feel like, hey, it's easier, but we have to protect ourselves. Just saying, in the longer term, there's a lot of implication to the habits we are now forming, or the habits we are refusing to form because we think we are faster doing it another way. Just think about it. Why we want to encourage you to do certain things in a certain way. We have the best interest. In making sure you are becoming a great software engineer. Not just a good software engineer, a great software engineer. And that's why we want to encourage you to follow certain procedures, certain standards, certain ways of thinking, certain ways of coming up with solutions, right? This is because, we have done this for many years, and that's why you are here with us today, because we believe in you as well, right? So you can do this. But sometimes it requires a little bit more effort at first to draw benefit from it later, just saying.
All right. Thank
you so much, Martin.
All right. So there are some few hands up. So Alex, do you have a question?
Yeah, thank you, Martin, for the clarification. Okay, I just wanted to ask, what's the difference between linking and linting?
Okay, so linting, L-I-N-T, is it's basically what you make your code. It's basically making your code more readable. Okay, it's focusing on readability matters. All right, so it's following some standards and making sure it's well structured and it's following some accepted standards of structuring your code, and that's all it is about. Okay, so Beatty, so for example, Beatty style is telling you how to structure your code, how much tabs you need to use, where do you need to use the curly braces, things like that. Okay, so it's all about writing a clean code. Okay, linting, L-I-N-T. Linking is a different process where you in the compilation process of the C files that is making your source code into an executable source code. you make sure your code has the necessary resources with it. Okay, so that's why linking means connecting the different parts of your code into so that it can be executed. It can become an executable file. Okay, so they have different meanings. Okay, linting is about readability. Linking is focused on, it's a step in the compilation process of C. Does that make sense?
Yeah, thank you.
All right. Aya, do you have a question? Aya, do you have a question?
No.
Okay.
That.
All right. Peace, do you have a question? No?
Yes, I do have a question.
Okay, go ahead.
Okay. Good afternoon, sir. Good afternoon, everyone.
Hi.
I'm so grateful for this meeting. I really have a challenge. Like, I understood what a pointer means. I understood array. I understood strings. But my challenge is that I've not yet understood how I can be able to put this code together to give the output given to us in the tags. I just don't know, because I've gone through the internet, I've seen examples, but still I just don't know how to put the code together.
So when solving a problem, okay, when solving a problem, the first thing you need to do is breaking it up into smaller chunks. Okay, so in the tasks provided to you, there will be listed specifications you need to do. Okay, so try to do one of them. Okay, not all of them at the same time. Just try to do one specification at a time. Okay, so when one specification is fulfilled, continue to the next one. Okay, so that's how you bring together. So I don't know if you were here when I talked about C in general, or learning in general.
No,
okay, so what I was saying is it's like a jigsaw puzzle. Okay, so what that means is you need to bring the pieces together one at a time, and it will form a bigger picture. Okay, so the first thing you need to do is list out the specifications of the task and try to break them into smaller chunks. Okay, so and try to fulfill one of the specifications, then continue to the next one, continue to the next one, and that way it will assemble into a bigger picture. Okay, hope that helps.
Okay, please, when you talk about specifications, please, sorry, what do you mean?
So when a task is given to you, so you'll be told that to write a script that does these things, right? Then after that, it tells you that you need to include this, you need to include this, and you need to have this, right? So what you do is you take one of the, for example, think of them as bullet points, and you take one of the bullet points and you break them into smaller chunks. Okay, so in order to do this, okay, in order to include this, what do I need to do? Okay, that's the question you'll be asking yourself. So when you do that, you'll start breaking things down into smaller chunks. Okay, so that way you will solve your problem very fast. All right, so when I talk about it, it looks like it's a long process, but it's not. Okay, it will help you out to solve problems faster instead. Okay, all right. All right, guys, so we're running out of time, so I need to run this command, and I will get back to you. I get back to you and answer any questions. Okay, so but I need to run this program and show you what we wrote so far. All right, so when running or when compiling our program, what we do is we use the GCC compiler, right? So the GCC compiler, as I showed you in the man pages or the manual pages, it has different options. very different options. But what we regularly use in our programs is those codes those options that show us the different error types, right? So we're going to use that. Okay, so what that means is we're going to use, for example, wall WALL or all warnings. That means all errors, things like that. Okay, so we're going to use those options. Okay, so all error. I suggest to find out what these options mean. I suggest you to read the manual pages. Okay, so we're not going to read about each and every option, what it means, because you have to read those things by yourself. Okay, so it's very clear. It's very clearly defined, so you don't have to worry about it. Just go to the manual pages and read what WALL means, or W error means, or W extra means, or pedantic, what pedantic means. Okay, so and the standard GNU 89. Okay, then give it the x1.c file and we run it. Did I make a spelling error? Yes. We have an error, so we're going to fix the errors here. Okay, so that's why these error files are these codes are these options are important here. Okay, so it's telling us that error C++ comments are not allowed in ISO C99. So we need to remove the one-liner. Okay, so we're going to remove it. That's fine. I just wanted to show you the code, the ways you can comment. So one of the things that the standards are suggesting is you don't need to use.
Joseph, can you make me co-host?
Yeah, sure. Yes, done, Martin. All right, so the standards or the options we're using, make sure that our files are are aligned with the standard, the accepted standards, and are error-free. Okay, so some of the things given to us here needs to be removed. So I'm going to remove the one-liner here. Okay, the one-line comment here. Okay, so it's going to be important. It's not going to be important. And after that, let's run it again, and we'll check what's remaining. Okay. So it's also we also have unused variables like unused parameters like argc and argv. We can remove those. So one thing you need to remember here is the options: the W all, the W errors, the W extra, the pedantic. What they are telling us is they're making sure there is no loose end, basically, or an error-prone code. So that's why it's right here. It says all warnings are being treated as errors. Okay, so that's why we're going to remove the parameters here. Okay. It's perfectly fine to remove them since we're not using them right now.
So as I said, the main function does not have a prototype. So,
yeah.
So we can either supply the arguments or we can remove them.
Yes, exactly. So then we run it, and our code follows all the standards specified by the options. Okay, so if we check right now, it gives us a.out, right? So a.out is our executable file. Okay, so one thing you need to see in a.out is, let's do a long version of listing. Okay, so it's an executable file here. Okay, so the X stands for that basically. Okay, so it's differently colored since it's executable and it can be executed. That's why in the permissions here we have the X here. Okay, all right, so now we can execute it using / a.out, and hello, you are 100 miles away. So we have our printout here. Okay, so this is how we execute and this is how we compile and execute a C function. Okay, a C program. So what we did is we used GCC, the compiler, and given it the options to treat any warnings as an error and different standards our code needs to follow, and we compile it, and that produced us an executable file. That executable file contains zeros and ones, and that zeros and ones can be executed as I've shown you right now. So let's see what the a.out contains. Okay, so as I said, it's zeros and ones, but the issue with zeros and ones is it's only understood by the right program in the machine. Okay, so if we do for example a less.a.out, it's going to be understood in a different way. Okay, if we feed this executable file to another program that accepts an executable file, it understands it in a different way. Okay, so if it's a video player, it might show a different random signals of video. Okay, for example, in less, it's going to show you a warning. So it says it's a binary file. Okay, so are you sure you want to see it? So I'm gonna say yes, and it shows you this random gibberish. Okay, so this random gibberish is not understandable by us, it's understandable by the machine. Okay, now this random interpretation is not a correct interpretation because we're interpreting this this executable file or this binary file by the wrong program. Okay, that's why it's showing you this. Okay, it's understanding a different language. Okay, so this binary file will only be understood by our computer itself. Okay, that's what I wanted to show you. All right, so we can also use in order to execute or compile our code, we can also use a make files. Okay, so let me remove the a.out for 1 second and let's use a make tool. Okay, so the make tool is a very the make program. It has been around for a long time. Okay, and it knows how to build a lot of things. Okay, so if we use make, that's another option. Okay, this is let's put it like this. It is an extra curricular understanding, but there are ways to use make files to run a few things. Okay, so I want to show you that. Okay, so we can also use the make program to execute our C code. Okay, so let's use make. I will explain what everything means. Okay, x1. So then it runs it. If we do this, it will print out ax1. So if I run ax1, it creates a binary file that we can execute. Okay, so the make program, as I said, it has been here for a long time. That means it knows a lot of it knows how to build a lot of things, including obviously C files. So the way it works is it has a lot dependencies declared in it, and those dependencies if those dependencies are made, the program is compiled and executed. Okay, so I wrote what I wrote here is make ex1, right? So our file name is ex1.c, right? So what the steps it's going to do is it's going to ask itself, does ex1 exist? Okay, a file that has no extensions, just ex1, does it exist? If it's no, okay, then is there another file that starts with an ex1? Okay, that's the next question it's going to ask itself. If that answers is yes, in our case, which is yes, because we have a file named ex1.c. Okay, so what it does is yes, it's called ex1.c. So do I know how to build a .c extension file? So Makefiles does know how to build .c extension files. So it's going to run the command. And 1 second, let me remove ex1. Then let's run make ex1, and it's going to run this command basically. Okay, this command is going to be run. So cc, cc is another C compiler, ex1.c, and output, that's an option, ex1. Okay, so it's going to output the binary file into a file named file called ex1. All right, so that's another way of using makefiles. Okay, so I'm gonna give you a documentation about makefiles on our Slack post after this session, and I need you to read about it, and we'll cover a few things about ex1 on our next live learning session. But
Joseph,
yeah.
there's a reason why Makefiles is the 28th C project in this curriculum. We will go into Makefiles later on. Right now, there's no need to worry about it.
Yeah, that's why I'm not covering deep in it, but I just wanted to show them that Makefiles, there is another way of compiling a C file.
Okay.
All right. So for today, we haven't covered a lot, but I hope this session was helpful for you guys. We will have another session tomorrow. We will announce the time and the link for it to join in. And yeah, thank you all for joining in. I hope it was a helpful session. Have a good day, guys.
Well, thank you so much, Joseph.
Good day.
Good day. See you on Slack.
Recording stopped.
All right.
Thanks,
Good night, guys.
Thanks everyone. Have a great night.
Thanks, Martin.